This is problem 3 from practice quiz 7. And the problem, I will read the problem, and as I'm reading the problem, I will extract the information that is necessary for me to complete the entire set of questions. The problem states, a middle school in Los Angeles is investigating how weather impacts the behavior of students. On average, the school reports 12 student altercations, fights or almost fights, per day, with a standard deviation of 3. I'll stop here. Here we're talking about a particular middle school, and so that would be my population. And this school reports 12 student altercations per day for its average. So here I'm going to write population, and this is giving me the mu, which is 12 fights per day, with a standard deviation for the population of 3. And then the problem, I'll continue with the problem here. However, the school believes that student altercation increase when it is windy outside. So here, on this sentence, the school believes that the fights will increase. So there's a direction. So my treatment is that it will increase when it's windy, and the direction is increase. And the problem continues. The school studies 4 specific days in which it was extremely windy. So even though we're not talking about particular people here, we're still talking about a count. And in this case, they're counting 4 days in which the treatment is seen. So here we're referring to the sample, and we have a sample of 4 days, so that's my n. And then the problem says during these 4 days, it found an average of 15.5 student altercations. So the M is 15.5 fights. And then finally it says, help this middle school determine whether the wind significantly increases, again there's the word increases, student altercations with an alpha of 0.05. So my last piece of information, I'll put it over here, is that my alpha equals 0.05. I have now placed the first 2 questions of the problem, question A and B. Question A states which test would be best to use, hypothesis test or the t-test. And again, to answer this question, we have to know if my population standard deviation was given. So under population, we did identify a standard deviation. We identified this sigma over here. And so for this reason, it is best to use a hypothesis test. As to question B, this test should be a 1-tell test or a 2-tell test. To identify the answer, we go to see if we identified a direction, and we did. It was to increase altercations, and so we know that this should be a 1-tell test. I placed question C here, and it says indicate whether there was a significant increase with statistical notation. Show all necessary work leading to your decision. So here, I'm essentially going to go through the hypothesis test process, except I do not need to use step 1. I do not need to identify any hypotheses since it was not required here. So really what I'm going to do is go from step 2, then to 3, and then finally 4. And step 2 requires me to, reset. Step 2 requires that I come up with my critical region, and that's what I'm going to do. From step 2, I need to know I need to know my alpha which is 0.05. I'm going to need to find alpha's z-value. And to do that, I'm going to go to my unit normal table, and under column C, I'll find the alpha and cross-reference it to column A. Since we said that this is a one-tel test, then under column C, I'm going to look up the entire alpha value, which is 0.05. Since this is a one-tel test and not a two-tel test, I don't need to divide by 2. And so when I look up under column C 0.05, I can cross-reference that to column A, which gives me 1.64. 1.65 is also applicable, but I'll just use 1.64 for this problem. Additionally, because it is an increase, because my direction told me to increase, I'm going to make this a z-score a positive. So my alpha z-score is 1.64. And now what I'm going to do down here is create a graph. And I'm going to identify this z-score here, plus 1.64. And I'm going to shade only one critical region, again because this is a one-tailed test. So there is my critical region. The next thing I'll do is step 3. And in step 3, I'm going to be calculating my standard error and my sample's z-score. For my standard error, the equation is, it's not S. My equation is sigma over the square root of n. My sigma comes from my population, and it is a 3. And my n comes from my sample, and it is 4 for 4 days. So I have 3 divided by 2, which gives me 1.5. And this is my standard error, my actual standard error. I'm now going to calculate my sample z-score. And my equation for that is m minus mu over standard error. My m is 15.5. My mu is 12. And my standard error, we just calculated it to be 1.5. 15.5 minus 12 is 3.5. I'm going to divide that by 1.5. And I am left with 2.33. So this is my sample's z-score, and that it is positive. Finally, for step 4, I will locate this z-score, this sample z-score on my graph, and it is 2.4. So I'm going to estimate it to be right there. That's my sample z, which is positive 2.33. And so in this case, it does land in the critical region. And so because it lands in the abnormal region, I accept the alternative and I reject the null if I were to use the hypothesis. But in this case, I'm just going to finish it up by writing my notation. And so it's z equals, and I'm going to put my sample z-score here, plus 2.33, comma, p is in fact less than 0.05. And the reason I know that is if I go down here to my sample z-score and I start shading, my blue shaded area is less than my red shaded area. And so we can assume now that yes, the wind does affect student altercations, and that it will increase the average amount of student altercations.